So the next implementation we're going to look at is a hybrid that's going to use the fork join framework to do the parallelism, but it's going to use the sequential streams framework to arrange the control flow of the application logic. And you'll see that that arguably is a little cleaner to read, depending on your point of view. So this is going to apply Java sequential streams and the Java fork join framework together. It's like a hybrid car. And you'll see that it's going to use this kind of interesting technique here, and we'll take a look at this, and you can decide if you like this visually better than the other one. So let's go ahead and walk through the code, which exists in this file. So now we're back in my IntelliJ project. We have FileCounterSequentialStreamTask, which also extends AbstractFileCounter. It's got two constructors, just like what we looked at before for FileCounter fork join task. One of them is the public one, which is used to get the initial folder into these particular object. And then the other one is the one that's used internally when we're doing the splitting up of the various pieces for each file that is in a folder. Let's take a look at the compute method. The compute method starts out identically to what we did before. We check to see if what we've got at this point in our recursive hierarchy is a file or not. If it's a file, we increment the file count by 1 or the document count by 1, and we return the length of the file. That's exactly what we did before. The beginning of the else part also looks very similar because we're going to call increment and set. Now things get different. So what we're going to do is we're going to use a Java sequential stream. And there's a whole bunch of ways to make a stream. We'll talk about a bunch of them. But here's a good one you need to be aware of because it shows up in assignment number 2. If you have an object, you can turn it into a stream by saying stream of. So we're going to take this list of files, which is actually, oddly enough, an array, but they call it list. But it's an array. It's a Java built-in array. And we're going to take that array, and we're going to convert it into a stream by saying stream of. Stream of is a factory method that takes some other type and turns it into a stream. Once we've got a stream of these files, we then use a so-called intermediate operation called map. Map is used to transform things. And what we do with map is we make ourselves a new FileCounterSequentialStreamTask with the file, which we now call temp, because I should probably just call it file. And then we say, we'll pass in the document count, the folder count at this point, and we then fork that. So we're going to end up here with a stream of fork join tasks. And we're then going to use the toList terminal operation, which we'll talk more about later, to trigger all the intermediate operation processing and then collect the results into an immutable list. So what comes back here, where I say var, if you see var up there, that's a more recent Java feature that says, you figure out the type compiler. I don't want to have to be bothered to type this out. And it tells us it's list of fork join tasks. So we have a list of fork join tasks using streams rather than using loops. Now, for something this simple, you might argue that the loop was actually a little easier, but there still are some benefits of using streams here. In particular, we don't have to worry about initializing this list. It's done automatically by the toList method. And there's some other benefits we'll talk about later. So we've forked everything off. We've got a list of fork join tasks. What we then do is, once again, we use the streams mechanism. We take that list and we convert the list into a stream. And you do that in Java streams by saying .stream. This makes a sequential stream. So we have a sequential stream of fork join tasks. And then we're going to use an intermediate operation called map to long, which we'll talk about later, which is also a method that does transformation. And it's going to join with each of the fork join tasks and will then return a long stream. So this is a stream of primitive types. And then we're going to sum them together. So the nice thing about this is once you kind of get your head around the wonderfulness of the functional programming abstraction and the paradigm of functional programming with streams, you're declaratively saying what to do, not writing loops and if statements and so on to do it. So here we're saying turn the list into a stream, join everything together, and sum the results. So that's the implementation that uses the hybrid Java sequential streams and fork join pool together.